Hello everyone, this is Tushar again with a new topic. Hope you all are doing fine. So there is a small request I want to make before the topic, that please subscribe and hit the bell icon so you get the notification when I upload a video. So today we will be discussing types of solar technologies which we use today to extract power from solar light. So you all know that there are many research has been done from a long time which we are using today to enhance the output from our solar setup. So today we will study about these topics. Let us start. So here I have pointed the different type of technologies which are currently available in the solar field. First is polycrystalline. As the name suggests, poly means multiple. So polycrystalline technology is used in the solar module in a way like the cell of the solar module are made up of more than one type of cells. So that are categorized as polycrystalline. Okay. Next one is monocrystalline. So monocrystalline is the technology which was used in the starting when the world started to extract the solar power from solar light. From that time we are using monocrystalline technology. In this, as the name suggests, there are only single type of solar cell which are selected to make the PV module so that we can extract the power. Then as the time goes, we understood that we only have one side of the solar module on which we can generate the power. For example, if we have a roof and we are installing a module here, so and a sun rays are coming from this side. Okay, so the researchers thought that why we are considering only one side of the solar module to collect the generation, collect the photons and light so that we can pass the current through it. So they made a transparent bifacial so that the light which is reflecting from the surface of the floor, that is also consumed from the reverse from the opposite direction of the PV module. So it is like a transparent type of wafer which is very thin, and the light is slightly can pass through both of the sides. But here there is but we doesn't apply any kind of shiny surface or paint or polish on this surface. We just use the bifacial kind of solar module here. So that technology was referred as bifacial. Okay. So then after that it comes the thin film. After we were limiting the area, limiting in the area on which we can install the solar module, then the researchers thought that why to limit on this aspect, that we want only a plain surface or a plain roof. Then they started to think that we can apply as we all know that there is the wafer, silicon wafer is very thin. It's like a normal like glass chip which can be broken from an instant jerk. Okay, so they tried to make a flexible sheet out of it and give a lamination so that it can be installed on any surface, whether it is a building. So the result was that all the big towers, commercial towers you can say, or any kind of residential towers, all the faces which were getting light on it straight from the sun or from any kind of reflection from any surface, these thin film technology of solar modules were installed on these. So you can think about, imagine that a whole building is covered with solar module, and whole building, so the face of of any side of a solar of a building is generating solar power through these thin films. Okay, so these are also currently used, but they are little bit expensive, so they out of go with the budget criteria. So most of the people doesn't like this thing, because there is a one drawback, or drawback also comes with this point, that when the modules are applied on the windows and the surface, you cannot open the windows more frequently, because there is a chance of getting them a crack or micro crack in them, which can hinder the process, which can result in the situation of multiple types of solar module attached in a single series. I will discuss about this topic in the different video, and talk about it in detail, how it is affected, and why we consider the to replace or just remove the broken or cracked solar module if it has a minor break also. Okay, so we talked about this as well. So next is the monoper. In this, the main thing was to reflect the sunlight so many times from the close range, so that it doesn't get to lose its irradiance in the path, and the reflection of the light is too sharp, so that it doesn't waste time, and also the rays can be occupied in the short period. For example, that this is a solar wafer in the module. In the thin film, we have considered that the reflection from the surface was coming from this side. So we just made an improvisation here, and we made this layer quite shiny and good for reflection. So when the rays enters here, it reflects the light back to the wafer, so that more irradiance can be captured. So I think you might have understood all these points and the techniques. So now you can understand which kind of technology of the solar module you want on your solar unit. And one thing more I want to share, that these all have different types of efficiency. So in the solar unit, efficiency is basically not related to the output. Efficiency related to the output with respect to the area. So if I consider monocrystalline, so it will occupy little more area than polycrystalline, but gives same output. So for example, if I say that you want to install a 4 kilowatt solar unit at your terrace, so you need nearly 25 to 6 meters of area. Okay, sorry, 25 into 6 feet, because 6 feet is the height of the module of a normal module. So you will nearly need approximately this much amount for monocrystalline. To get the same amount, you need for getting the 4 kilowatt for polycrystalline technique, you will need little less space and you will get the same output. So efficiency is not related to the output, it is related to the area on which it is being spread on the surface. So I think I made some points clear and elaborated for you, so that you can better understand these things. So please like and subscribe, and thanks for being so patient listeners.